Okay, if $2,000 is invested in a bank account at an interest rate of 5% per year, so now we're doing this. This is an application section. So 6.7 is all kinds of real life applications of exponentials and logarithms. We're trying to say where in the real world do we use exponentials and logs, which we've been studying for this whole chapter. This is the end of chapter 6. We've been studying exponentials and logs. So over here at the very end, we're going to apply them. We're going to say, where are these used in the real world? Well, financial situations use them a lot. So if you take $2,000 and you invest in a bank account at 5% per year, find the amount in the bank after 7 years if interest is compounded annually. Okay, so I need to give you the formula for that. So the formula is this is for compound interest formula. How does it work? What's the compound interest formula? A equals P, 1 plus R over N to the NT. There's our formula for compound interest. And what are the different parts here? A is the amount later. P is the principal invested at the start. R, you might guess, R is the rate of interest. T is the time in years. And then what is N? Well, N is a little tricky. N equals the number of compoundings per year. What are we talking about? Well, N equals 1 if it's compounded annually, once a year. N equals 2 if it's compounded semi-annually. That means twice a year. N equals 4 if it's compounded quarterly. Sometimes they'll say compounded quarterly. That's 4 times a year. N equals, what else do they say? I think it's about it, quarterly. Oh, monthly. Yeah, 12 if they say compounded monthly. I guess if they said daily, we would do through 360 or 365. They would tell us on the problem. I'll just leave it at that. Monthly. So N changes depending on how often the money is being compounded. Okay, so let's use that formula then. And then the last one, continuous, that has a special formula. I'll show you that here at the end. Let's go back up here now. So, okay, so I'm going to use, for this first one, A, the amount equals P, the principal, that's the $2,000. That's the principal invested, that's P. $2,000 is invested. 1 plus R, what's the interest rate? 5%. You got to make that 0.05. Got to be a decimal. 0.05 all over N. I should put that. The decimal rate. 0.05 over N. Now N, they're compounding annually. So that means N is 1 once per year. Right here. N is 1 for compounded annually. That means 1 time a year. To the power NT. 1. And what was T? 7 years. That's T equals 7. 1 times 7. All right, so on your calculator, you've got to put that in. Just like you see it right here. Just type that into your calculator. I'll do mine right now. And I'm getting, what am I getting? 28. 14, just round to the nearest penny, I assume. Yeah, we'll just go to the nearest penny. $2,814.20. So your $2,000 will grow to become $2,814.20 after 7 years, being compounded at 5% interest. So you got a free $800 notice. Well, it took 7 years. And you had to leave your $2,000 sitting in there. You couldn't do anything with your $2,000 for 7 years. And it grew by 5% per year, came up to $2,814.20. Now, the next question, they're going to say compounded quarterly. So that's 4 times a year, right? Everything else is pretty much the same. So $2,000 put in quarterly, so at 5%, and this is n times t, so it's 4 times t is still 7 years. So this part up here is going to be 28, isn't it? So type that into your calculator. That power is 28 because it's n times t. See how I got that? N times t. The n is 4, and this is n, and this is t. Set t is 7 years. So the power is 28. So 2,000 times 1 plus 0.05 divided by 4. So you need to figure out that power ahead of time. So when I type it into my calculator, I go 2,000, 1 plus 0.05 divided by 4 with parentheses, those parentheses I'm using. To the power, I use the up arrow, but on my calculator, but whatever your power button is, 28. And I'm getting 2831.98. So look, it's a little more money, isn't it? Your 2,000 grew to become $2,831.98. So you made a little more money. Why? Because the interest is compounded a little more frequently. It's the same interest rate, 5%, same amount of time, 7 years, started with the same investment. But if you compound it a little more frequently, quarterly, if they offer quarterly compounding, it grows a slight bit faster. Now, let's try it again. Now we're going to go 7 years compounded monthly. Well, monthly is 12, as it says right down here, right? 12 times a year, monthly compounding, 12 times a year. So that's going to be, so the amount will be again 2,000, 1 plus 0.05 over n is 12 to the 12 times 7. And then let's just figure out what is 12 times 7, that's 84. So this right here, this right here is 84. So I'm going to type in, so yeah, so just type it into your calculator like that. Use parentheses. And I'm getting 2836.07. So it's even slightly higher, isn't it? Now it's up to 2836. See how it's, again, it's the same 5% for 7 years, initial investment, $2,000, same thing, but then we're compounding monthly, even a little more frequently, gives a little better. Now, finally, they're saying compounded continuously. Now, what's that? That's a whole different formula. So let me give it to you. It's actually an easier formula. So continuous compounding, you use A equals P e to the RT. I call it the PERT equation. So you see all the P, the R, and the T, but you use the E, like that special E. Where'd that come from? Well, it's kind of a long story, an interesting story. I'd be glad to show you more about it if you want at a separate time, but let's just use, it's a whole different formula we use for continuous compounding. We don't use this formula. This formula over here is only when they compound, quarterly or monthly or annually or whatever. But if they continuous, that's a That's a very important word, continuous compounding. You got to use this formula. Okay, so let's use it. So the amount will be, the principal again is 2,000. E to the power of R times T. What's R? R is still 5% times T, which is still 7 years. There's what you type into your calculator. Use the up arrow or the power button right there, E to the power. So 2,000 times E to the power of 0.05 times 7. I'm getting 2838.14 cents. 135, so rounds to 14. So that's even a little higher. So continuously, you might wonder, how do they compound continuously? Well, it's actually a concept. Somebody doesn't actually physically do something. They just offer continuous compounded interest. So it's even a little bit better, isn't it? See how they just got higher and higher the more frequently we compounded. Annually was once a year, quarterly 4 times a year, monthly 12 times a year, continuous, that's infinite times a year, came up even a little higher, a little better. So there we go. So for the first three, we plug into the formula A equals P 1 plus R over N to the NT, where N is the number of compoundings per year. It's 1 for annually, 2 for semi-annually, twice a year, 4 for quarterly, 4 times a year, 12 for monthly, 12 times a year. And the last part was continuous compounding. And that's a whole different formula we use. A equals PERT. And you plug in P, the R, and the T, and you get your answer. There we go.